My name is Julian Podgórski. I'm a PhD student at the Institute of Geophysics of Polish Academy of Sciences. Today I'm going to talk about glaciospeleology. It's a presentation. The slides and the material has been prepared by Jerzy Giżejewski from the same institute as me, and I'm delivering to you the English language version of this lesson. And here on the first slide, you can see the three images that are somehow related to glaciospeleology. Two of them are two books which Jerzy is recommending to you that are dealing with the matter of sightseeing glacial caves. One of them, the vertical caving, is concerned with technicalities of vertical caving in general, while the other, the one in Spanish, is more about why it's worth to study ice caves in general. And in the middle, you can see a person who's actually doing the glaciospeleology. So, referring to the title, at the end, we will learn the answer if glaciospeleology is more of a hobby, sport, or science. Now, why do people even enter caves? That could be a first question we could ask. Why do we even go there underground? And everyone who is working with caves has their own answer. And a famous English Himalayist, Mallory, could be quoted here. He was asked once, why do you want to go to Mount Everest? He was famous for climbing Mount Everest. And his answer was simply, well, because this mountain is there and it can be used, it can be climbed. And the same goes with caves. People go there just for the sake of sightseeing because they are nice, they look nice, and once you sightsee every cave that's easily accessible, there are a lot of caves that are prepared, for example, for tourists, and they're really easy to enter and to look at. Once you see all of them, many people want to go into deeper, smaller caves. To go to caves to do any kind of cave climbing, so to say, we need an environment where those caves can be found. If there are no caves, there's no speleology. And this image here shows glaciers and mountains close to Polish Polar Station, and it can be assumed that all of them have at least one cave, one ice cave that can be explored. Sometimes, and very often, when there's a lot of snow covering a glacier, we can only see an entrance to a cave, only the biggest entrance. So caves in glaciers can have many entrances, many wells that lead to them, but in case of thick snow cover, only the biggest holes can be found by people. But in summer, when all the snow melts and goes away, those places, those entrances and wells are easily revealed, and they can be seen and discovered by people. They are, as you can see on these photographs, both beautiful places and also slightly scary places. They are very deep holes in the ice with steep walls. A deep crevasse can turn into a crevasse in the ice that can be several tens of meters deep, can turn into a cave, or we can see, like on the image on the right, a stream that's flowing along the ice and suddenly disappearing into a hole in the ice. In summer, it's not always safe to go to ice caves. So in situation like this, on these images, people are going there, discovering those entrances, putting very long, tall flags just to mark that the entrance is here, and go back there in winter. Now, ice caving, just as non-touristic speleology, requires quite a formidable amount of specialist gear, specialist equipment. And the first thing and very, very essential thing are ropes. There is actually the knowledge about ropes, how to care of them, how to wash them, how to bind them, is a whole, so to say, field of knowledge that has to be mastered by anyone wanting to go into the ice caves. And ropes can be used, well, most basically to move up and down, but also to secure ourselves in deep wells, or to fix something inside the cave. There are some personal items that can or sometimes should be used. On the left, you can see a waterproof suit, the orange costume, the orange suit. It's waterproof and it's quite warm inside, and it's very good actually to have it on ourselves when going into an ice cave. Even if on the surface, even if we're going there in winter and on the surface of the glacier there's no flowing water, it may happen so that deep inside the cave there will be streams or even small lakes, and such waterproof suit will be absolutely necessary. The second thing that is very essential is light. On the right at the top you can see a helmet. People are wearing helmets a lot in caves, in ice caves as well, with a carbide lamp. Inside the cave it's actually dark. There are very often there are no light sources, and there's not much light going in from the outside, so it's quite dark, and it's necessary to have some kind of lamp or light source. And below you can see two harnesses. They are put on legs and on the chest of a person who's going to a cave, and are used to fix ropes and various different hooks and items that are necessary to keep us safe. And on the bottom there are boots. I will tell you a little bit about those things in the next few slides. This is the carbide lamp, as I said, and here we can see how a lamp like this works. There is a flame, and inside this black little box there is a chemical compound called carbide. Its important feature for us is that when it touches water in any way, when it comes to contact with water, the chemical reaction produces flammable gas. And this gas is then routed through the cord, through the rubber pipe, which you can see here as a black one, and then the silver one, into a small lighter that lights this flammable gas. And this way a small, very bright flame appears that can light the route before us in a cave. A lamp like this can work for many hours on a single load of carbide and water. So they are very good for cavemen, because caveman is a bad word. Cave explorers, because they give bright light for many hours and they don't need electrical equipment to them. Now these things here are boots. Comfortable and sturdy boots are really important when going to a cave and an ice cave as well. But the interesting thing here are the crampons. The crampons are those spikes that are attached to the shoe at the bottom, and they are used to climb the ice mostly, to walk on ice. The four teeth of those crampons, the four spikes at the front, are used for vertical climbing. If we want to go up an ice wall, then we can just kick with those spikes, and then our shoes are somewhat attached to this wall, and we can climb an ice wall with them. And the rest of the spikes, the ones in the back, the eight spikes along the shoe on sides, are used to just walk on flat ice, so that people who are walking on ice don't fall, don't slip and fall. They can use spikes that gave them firm grip to the surface. Now this is an ice axe. It's a device that's used by all winter climbers, regardless of whether they're going to an ice cave or to high mountains or to a normal cave. It's used much more often when approaching a cave. When we, for example, we or people who are exploring the caves need to go up a glacier or to cover some ice hill or climb a little mountain, that's where they're used. Inside of ice caves, they are less useful than outside when climbing glaciers. And here we can see a small rundown of more specialist climbing gear. The two things we can see here, the ones on the right, the 4 items on the left, sorry, the one that's blue and red and gold and red again. They're ascenders and descenders. They're ascenders, the blue and gold one. I will tell you a bit more on how they work, but they're used to climb up a rope. The 2 red things are pulleys that can be used to transport things. They make it easier to for example, pull something up using a rope, like with a crane. The ice axe here is the same one I have shown you before. The thing with screw on the far right is an ice hook, and these are really useful for climbing ice, because people can easily screw them into the ice, and they form a very firm, very solid sort of hook to which you can attach ropes or yourselves or some gear or carbines. And the 2 things at the bottom are known as carabiner. It's probably the most well-known climbing gear item, and they are simply used to connect things with one another. So we can attach ropes and people and items and hooks with each another easily and quickly. Now this blue or gold thing is known as crawl ascender, and it is used to climb a rope. When we have a rope that's hanging from the top of some cave to the bottom, and we're hanging on this rope, we can use this little item to climb up this rope. It is mounted fast on the rope, and the ascender, this little thing, cannot go down. If we pull it down, it just simply won't go. But when we pull up, it's moving quite freely. So a person, just like on the drawing on the left, a person can hold the ascender like this and just pull himself or herself up, and with use of legs they can pull legs up again, and then move the ascender up, pull yourself with legs, pull the ascender up, and this way a person can climb the rope, the free hanging rope, even without helping themselves with ice wall or rock wall. It can be a quite fast way of getting up. Very trained people who are very well experienced with caving can even cover 1 meter every second, so they can climb with a speed of 1 meter per second. But it is only used for a single quick run, so to say. When we have when people have a single wall that they need to climb up, then they use it, but probably not for any long-term, long-distance climbing. A crawl ascender, as you can see on this bigger image, has a special sign with a person's silhouette pointing up that tells you where is the up side and where is the down side, so that you can mount it correctly on the rope. If you mount an ascender the other way around, in the wrong way, then it will not work, because then the principle will be reversed. Usually ascender goes freely up and doesn't go down, but if you put it the other way around, it will go freely down and not at all up, and that's certainly not what you want to do in a cave. Now, the opposite of an ascender is a descender. So it's a device that can be put on a rope to allow a climber to go down safe, so to say. It is used for sliding down on a free-hanging rope. It's attached to a harness that a climber is wearing and to the rope, and by means of pulling the rope, the climber can steer how fast do they slide down. So a descender allows for safe descending with a reasonable speed without simply falling, and again without much need of having a lot of equipment on the wall. There's also a lot of security warnings on the leaflet that's attached to each of those devices. So you can see that they say that the 2 meters per second is the maximal speed of this device. Sorry. If you go faster than that, it's not safe anymore and you can fall. It also says that you must not ever leave the rope hanging freely. You always need to hold it and to pull it to keep control over how are you sliding down, how fast or how slow, or even not at all. Now, a little bit different topic maybe. We're moving on from the equipment. Here's a map of a glacier that's called Hans Brien, and it's very close to the Polish polar station in Hornsund. And on this map you can see those colorful lines, and each of those lines indicate a depression in the terrain, some kind of niche of lowering, a valley maybe, where water can be found flowing during the summer. And the water that's flowing on glacier usually need to go somewhere, and it goes into wells that are carved into glacier or into crevices. And this water that's flowing along the glacier and washes in is building out caves and corridors inside. We shouldn't go there. People should not go to ice caves when water is flowing. It's not safe. It can happen that a person will get sort of stuck in a wall like this, and the whole water that's coming from above will actually accumulate, pool up on the head of such person. So it's not really good, reasonable idea to move into those caves in summer, but in winter it's safer when there's no water flow from the top. And here you can see again a canyon, an ice canyon with quite a big river. The hole in the foreground of the image is an entrance to an ice cave. And as you can see, the stream is quite fast, quite rapid, and it's moving a lot of water inside into the glacier. And this water then is able to carve caves, as you can see here. This one hole here has been carved by flowing water, not by humans or something else. And that's another case of the same. This river is a little bit calmer, slower, but still it's able to dig in a canyon in ice. Now let's try to go enter the cave. In summer, it's the entrance for the well, the ice well, looks like this. If we want to enter this in winter, as I said, we can put in some ice hooks at the edge, so we can attach ropes to something safe and rather fast, and then go move down with our ropes. And that's how it looks. Sorry for that little break. That's a glaciospeleologist in action. Someone has taken a picture of this person when they were moving down. So this picture is taken from above, and you can see the ropes, and maybe not all of those devices I have been talking to you, but you can see he has or she crampons or on their shoes, and there's a lot of ropes and the carbide lamp on top of their helmet. This is the very same person, but this time it's photographed from below, from the bottom of the cave. The cave can even have several tens of meters of depth, so such movement down can last for several minutes. And the only light source you can have there when you're climbing ice caves is your own lamp, as you can see, which is not only a little bit scary when you're alone down there, but also allows for really good looking photographs and nice photo shoots. Sometimes it happens that the corridors in caves are very narrow, like on the image on the left. The person can hardly even move through a crack, and the person has to squeeze through. In this case, they managed, they went through, but in some cases, it's so that the space is just too narrow for us to move. But the ice is actually brittle, and theoretically, we could use ice axe or some other device to just blow our way through, but it's really not recommended. Really not recommended. It's in the bottom of the glacier. It is a little bit warmer, so if we try to change the geometry, the shapes of those corridors, we don't know if they won't change and move back when we're trying to go back, and then getting stuck inside an ice cave is certainly not a pleasant option. And on the right, you can see a climber, a nice glaciospeleologist, who is putting in an ice screw so that they can use it to continue their trip. You can see that up there above the person, above the red helmet, there is a corridor, a dark corridor, and they probably want to go up and need some ice screw to serve as a supporting point to climb up there. Inside the glacier, there are not only vertical corridors, not only wells, but there are also sloping corridors that go more or less down, and they can be walked, like on the image on the left. The two people here are they don't need to use their ropes in this piece of the glacial corridor, because they can just walk down. as it is relatively the slope is not steep anymore. And all the forms, the land forms, so to say, the cave forms you can see on both of those images are made of ice and made of water. During ablation season, because all those images have been made in winter, during ablation season in summer when ice is melting and water is flowing, all those corridors, most of them are at least partially filled with water flowing from above. And this water is creating those forms. For example, those ripples on the left image are created by flowing water, or the stalactites and stalagmites that's hanging from the ice from the cellars of ice caves are also made of water that's trickling down from above. And these are very similar, those ripples, for example, are very similar to ripples that can be found in the sea and can be used to infer about the direction of the flow for scientists. On the other side, these icicles are very structurally similar to actual karst stalactites and stalagmites, and the science that's used in rock caves can be sometimes used in ice caves to get some knowledge about their formation. Sometimes, even if we go in winter, even if we're quite sure that there's no water on top of the glacier, it can happen that there is water at the bottom of the glacier, because it is sometimes warmer deep in the glacier than on the top of the glacier. And on the left picture, you can see a very small channel, and it's even no, it's not a river. It's a stream of water that's very shallow, and people just can walk on this stream. Sorry. But on the right picture, you can see that sometimes a glaciospeleologist is up for a surprise, and that's when this waterproof suit is actually really useful to have. The water is often in ice caves accumulating in corners of corridors. So sometimes it can happen that a person is moving down on the rope and suddenly their legs are in water. It can happen in an ice cave. That's no big deal, I guess. Now, when sightseeing an ice cave, it's not only that we're looking at beautiful landforms, at beautiful corridors and stalactites, but also people who are walking those caves or exploring them are trying to make maps. To do a map of an ice cave, one has to make a big number of measurements. For example, how far did we go already? How long was a shaft? How many different forms could be seen on the bottom? And here are two examples of cross sections of Spitsbergen, of ice caves in glaciers in Spitsbergen. We can see that they follow slightly a similar scheme. First, there's a very long well, a shaft, an almost vertical shaft that had to be covered by the climbers. You can see on the left picture in the Sima Eimfjelltaven, it's 50 meters deep. And afterwards, you have several, so to say, steps. They're much bigger than steps. They're a few meters tall. So there are cascades more than steps, which were formed by water flowing from above and hitting the ice. The same more or less happens in Sima Felix, when we have a 90-meter tall well, 90-meter tall shaft, after which there's slightly cascading uneven surface. Caves are not only vertical, it's not only a vertical shaft with some stream underneath, they can also be more can also be more like horizontal. And here we can see the bottom of the glacier, and underneath it there's water flowing on the contact between the ice bottom and the surface, the rocks. There's water flow, and the whole water that's coming from the top of the glacier is passing through those caves to the bottom of the glacier and then flowing on further to the sea probably, or to a river, to a glacial river. It is really quite complicated. As you can see, there's a lot of chambers and corridors between them, and maybe even wells. And to build a map like this takes a really long time and very many precise measurements that have to be taken by scientists who are glaciospeleologists at the same time. So now we learn that there are people who go to caves not only for excitement and for sightseeing, but also for science and for actual measurements. And this is a photograph from the measurement campaign that was used to make this map of ice caves. And we can see that this ice cave is actually very big. It's big enough for people to build a camp. The bluish thing at the back, it's actually a tent. Those people were living there for a few days because the measurements that are needed to map an ice cave in a good way require many days. There's a lot of things to be measured. And it would not be economical to go to this cave every day, to live in, for example, Polish Polar Station, and every day spend 4 or 5 or 6 hours to travel from the station to the cave. That's why the people took tents and equipment and clothing and sleep bags and everything, and just moved in for a few days to live beneath the glacier. In winter water doesn't melt, so it's quite safe to stay there for this time. There's no threat of sudden flood or that ice will collapse on their heads. It won't happen, so it's quite safe to stay there, obviously not forever, just for some limited time. And here also you can see some insight. You can get some insight to how the glacier looks at the very bottom. If you're ever wondering what's underneath the glacier, well, that's the answer. A lot of sand, mud, rocks, stones that are all merged together by the moving glacier and quite wet from the water that's present there. In summer, this area is filled with flowing water underneath the glacier. Just like I told you, there are channels that transfer the water from above to the sea. In summer, but in winter it's quite safe to live and walk there. Again, a photograph from beneath a glacier. That's a subglacial corridor, which has a small river flowing in even in winter, as we can see. The water flow is forming all the ice and landforms that we can see. So the smooth lines we can see, and those ice spikes, for example, and the layered black and white patterns are all formed with flowing water that's carrying a lot of sediment, a lot of content in it, and it's building such nice landforms. In summer, the river can fill the cave to very big height. As you can see here, that's a person standing there, and it's like quite okay. It looks like a normal stream, but in summer it goes as far as all the carvings in the ice. So the whole of this chamber of this channel is filled with water in summer. Now, once that we have a lot of observation, let's turn them into some knowledge. So for almost the end of the lesson, we will get to know how those caves are are formed, how is a cave corridor created when there's full water saturation, where there's really a lot of water. They need a starting point. There needs to be some weakness in ice that can be used by water to exploit it. So at the top image, we can see how it looks. There's some little crack in the ice, in the middle of it, and the water that's flowing is a little bit, it's slightly widening this crack. And once it's wider, there's more water flowing in, the pressure is bigger, and the bigger pressure means more force to widen the crack. And this way it's flowing stronger and stronger until we get this sort of more or less round cross section of a channel. And at the bottom you can see what happens when the channel is already formed. The first image on the bottom is the same one as the last one on the top. In summer there's full saturation of water, but then the autumn comes, there's less water coming in, so there's a table of water is showing up, and the force that's carving the material out of the glacier is getting stronger in different parts. So a sort of a notch is formed, a spike in the ice, in the wall, that can tell us about an older level of water. And the later we are during the year, the closer to winter, the less water there is in this whole corridor, and the carving profile is different. It's not anymore, the pressure is not big anymore to widen the whole channel, but the force is concentrated at the bottom. So close to the winter, or in winter, where there is really not a really small amount of water flowing comparing to summer, the corridor is only being made deeper and deeper instead of wider and wider. And that's the situation on those last pictures on the lower graph that we can see. Click here. This river here, this small calm stream, is the one thing on the last image, while in summer we are moving to this stage at the first graph of the bottom image, and everything is filled with large amounts of water. And now that's a summary of it's a scheme of a glacier, and the whole research that's done underneath the glacier, both the observations in caves and all the theoretical science I have shown you on the previous slides, are preparation to make an intersection of a glacier. To build an intersection like this, and it's only a scheme, it's not an actual glacier, it takes measurements from many caves, so a lot of speleologists need to go down and take measurements, and also some theory to back it up and to connect those measurements with each other, and with knowledge that, for example, hydrologists have about the amount of water flowing from beneath the glacier. So as you can see, this glaciospeleology is very important for glacial science, for glaciology. So, okay, maybe not yet. Maybe just a short summary. Maybe I can do this on this slide. So coming back to the title question, is it hobby or is it sport or is it science, the glaciospeleology? Well, I guess it seems that it's a little bit of everything. It really requires some knowledge and some caving experience to go into an ice cave, and some technical knowledge about ropes and those devices and ice axes, as I have been showing you. And as long as we're going there just for sightseeing, it's not really a science, it's then more of hobby and sport. But once a person goes into an ice cave, they become curious. How are they formed? Why do they look like that? And then they start investigating and maybe even start making measurements or get involved with some scientific project And then this hobby and sport that was first supposed to just see nice caves becomes science with actual measurements and actual hypothesis and actual knowledge. So to conclude, we could say that glaciospeleology is a sport and hobby which can have a lot of scientific meaning and can allow us to achieve scientific goals. Thank you for your attention on this lesson. If you have any questions, please ask them in the chat. I will try to answer them.